Welcome to Hartman Math. This is lesson 6-7, the unit circle. We're going to focus on sine and cosine. Before we get to that, we're going to look at sketching an angle in the quadrant plane. So this is from a trigonometry perspective in standard position. We'll talk about what that means. We're also going to determine the quadrant that the angle resides in. And to set this up, we're going to start by kind of labeling our quadrant angle. Straight to the right is 0 degrees. And then if we rotate to a right angle up top, that's going to be 90 degrees up top. And then another 90 puts us straight left at 180 degrees. Another 90 degrees puts us at 270 degrees. Another 90 coterminal landing in the same spot as 0 degrees is 360 degrees. So in terms of one rotation, anything between 0 and 90 degrees, we'd say quadrant 1, 2, 3, 4. When we sketch an angle in standard position, we start with our initial side being on the positive side of the x-axis. So we call that the initial side. From the origin straight right, and then we're going to rotate that 190 degrees. So we rotate it to 90 to 180, keep going, and then that side there is going to be called the terminal side, where we stop. And we're always going to show what I call the arrow of rotation. We started here, we rotated this way, so we're going to show the arrow of rotation, arrow pointing that we went in this direction, and that represents 190 degrees. Our quadrants are 1, 2, 3, and 4. And we can see right here that the 190 degrees is going to be quadrant 3, or determine the quadrant. All right, go ahead and pause here. I want to sketch a 75-degree angle with an initial side and a terminal side and an arrow of rotation, and determine which quadrant the angle is in. Pause here till you're ready. There's our initial side. There's the terminal side, not quite to 90 degrees. There's our arrow of rotation. And we are in quadrant 1. All right, so just a reminder back from the right triangle trigonometry, which is going to come into play here. We've got sine, cosine, tangent. Sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, tangent being opposite over adjacent. So in the unit circle, we know that the radius is going to be 1. So we're going to start by looking at, well, how would we define sine theta? We know that sine theta is going to be opposite divided by hypotenuse. And according to our coordinates here of this point that's on the unit circle at a point of x comma y, it means we've gone right x and we've gone up y. X, y. So opposite would be this leg here, which is y. Y divided by hypotenuse is 1. So y divided by 1 is y. What that tells us is that if we're on the unit circle, the sine of theta will be the y-coordinate. So if we have the coordinates, we're trying to evaluate the sine of a particular angle, and we know the coordinates that are associated with that angle, it's just the y-coordinate as long as we're on the unit circle. So it probably would be handy to have, from our previous lesson, your paper plate unit circle. But before we get to that, example number 2, we are given the fact that this is on a unit circle. We could verify that if we wanted to by squaring both of these, adding them together, square rooting by the Pythagorean theorem. If you get 1, then it's on the unit circle. If you did that, you would find out that it is 1. This is on the unit circle. So here's our theta right there. Here's our point. Sine of theta, we've just discovered, sine of theta is y. So here's the y coordinate. That's the sine of theta. All right, different one here. Pause for the your turn. You're evaluating the sine of theta. Sine of theta is the y coordinate. Y coordinate is 3/5. Sine of that angle, theta, is 3/5. And we would be talking about that angle right there. So what about, just in terms of general, in terms of some of our key angles, like the sine of 30 degrees? According to our paper plate unit circle, we go to 30 degrees, and sine is the y coordinate, and right there it says the point is square root of 3/2 comma 1/2, so the y coordinate is 1/2, so the sine of 30 degrees is 1/2. What about the sine of 90 degrees? Well, that's straight up, and that's where it says 0 comma 1, so the sine of 90 degrees is 1. Sine of 135 degrees, over here in quadrant number 2, it says that our coordinates are negative square root of 2/2, comma, square root of 2/2. We're looking for the y coordinate. That's sine square root of 2/2. 240 degrees takes us into quadrant 3. Negative 1/2, comma, negative square root of 3/2. Sine is the y coordinate, negative square root of 3/2. All right, pause here as you determine sine of 180 degrees and sine of 330 degrees. All right, sine of 180 degrees, the coordinates are negative 1 comma 0, so the y coordinate 0. And the sine of 330 degrees, square root of 3/2, comma, negative 1/2. So we're talking about negative 1/2 for the sine value. What about cosine of theta? Back to our unit circle, point on the unit circle being x comma y. We have a hypotenuse of 1 because the radius is 1. That's what defines a unit circle. Cosine of theta we know is adjacent divided by hypotenuse. Here's the adjacent leg, and that is the x coordinate. The distance here, since it's x, that's the distance from the origin to here. That's x. So x divided by 1 is x. So on the unit circle, cosine of theta will be the x coordinate. Example number 4, we've got a point, there's our theta. What is the cosine of theta? Cosine of theta is the x coordinate, so it must be 5 over the square root of 13. Your turn. So cosine of theta is the x coordinate. That is negative 4/5. Cosine of 30 degrees. We go back to our coordinates for our key angles. For 30 degrees, we're looking for the x coordinate. That's the square root of 3/2. 90 degrees, straight up, the x coordinate is 0. 135 degrees out in quadrant number 2. Straight diagonal, the x-coordinate, negative square root of 2 over 2. (240 degrees), that's my blue line, x-coordinate, negative 1/2. Your turn. Pause here. We've got both of those. Straight left, 180 degrees. The x-coordinate's negative 1. And straight, well, not straight right, but to the right in quadrant number 4 on green line for me there. X-coordinate is square root of 3 over 2. That's it for today. I'll see you next time.